This is section 11.1, ratio and proportion. So remember that you need to be taking notes throughout this lesson because you're going to be turning those in for homework. So first let's talk about what a ratio is. A ratio is just a way of comparing two quantities. So we could say like 1 over 2, and this could mean something like there's one boy for every 2 girls in a class. And a proportion is just stating that two ratios are equal. So we could say that this at 1/2 is equal to, and then 2 over 4. So that would be something like there are 2 boys for every 4 girls in a class. So 1/2 is equal to 2/4. Now when we're solving ratio and proportion problems, we're going to end up with something like part A. So part A says 2 over 3 is equal to 3 over W. So in order to solve this, we need to use what is called the cross product property. So let's look back up at our above example. So the cross product property tells us that we can multiply diagonally like this. We multiply 4 and 1, and we can multiply 2 and 2. So when we do that, well, 4 times 1, this would give us 4 times 1 is equal to 2 times 2. Well, 4 times 1, that's 4. So 4 is equal to, and then 2 times 2. 2 times 2 is 4. So 4 is equal to 4. So we want to use this property when we are solving proportion problems like we have in part A. So when we're doing this, let's use the cross product property to solve this proportion. So we multiply diagonally like this. So we multiply 2 and W, and we multiply 3 and 3. So now we can rewrite this proportion as 2W is equal to 3 times 3. So this means we have 2W is equal to 9. And now we just need to isolate W to solve for it. So dividing both sides by 2, we are left with W is equal to 9 over 2. And that would be our solution. We can always take this solution that we have and plug it back into the original equation to check to see if it's right. And in this case, it does work. So let's look at a little more involved problem. So now we want to solve this proportion. So we have 10 over t is equal to 2t over 5. Now we still want to use our cross product property. So once again, that means that we multiply diagonally. So we'll multiply 5 and 10, and then t and 2t. So this would give us 10 times 5 is equal to t times 2t. Alright, so 10 times 5 is 50. So 50 is equal to t times 2t. Remember, that's 2t squared. Alright, so we still want to isolate t. So to solve for t, first thing we need to do is divide both sides by 2. So now we have 25 is equal to t squared. And then to get rid of the squared part, we need to take the square root of both sides. So we'll take the square root, 25 square root of t squared. Now remember, we don't know if t is positive or negative, so we need the plus or minus in front of the square root. So this leaves us with plus or minus 5 is equal to t. And now we're done. So this was our solution, right? Notice that we have two different solutions. Since we have two different solutions, I think it's worth our time to check whether or not they work. So by check, remember, that means to plug them back into the original equation. So first let's do t is equal to positive 5. So we'll take our original equation, so it's 10 over t, and t is 5 in this case. So we'd say 10 over 5 is equal to 2 times t, which is 5, over 5. So 10 over 5, this is equal to 2, and then 2 times 5 is 10 divided by 5 is 2. So that one works. That's a good solution. Now let's check t is equal to negative 5. So we want to do the same thing. So we say 10 over t, in this case t is negative 5, is equal to 2 times t, so 2 times negative 5 over 5. Well, 10 divided by negative 5, that's negative 2. And then 2 times negative 5 is negative 10 over 5 is equal to negative 2. So that one works as well. All right, let's look at one more. Let's look at one more example. So we have this. Negative 3 over d is equal to d minus 3 over 2d. So we still want to be using our cross product property. So this gives us 2d times negative 3 and d times d minus 3. Alright, so we get negative 3 times 2d is equal to d times d minus 3. Alright, so negative 3 times 2d, this will give us a negative 6d, is equal to, and then d times d minus 3, this will be d squared minus 3d. Alright, now that we have this, we want to get everything to the same side. To get everything to the same side, we can add 6d to both sides. And this would leave us with 0 is equal to, and then we still have a d squared, and then minus 3d plus 6d is going to leave us with a plus 3d. Alright, now notice that each term here, the d squared and the 3d, have a d in common. So we could rewrite this as d0 is equal to d times d plus 3, right? So we can, since they both have a d in common, we can factor out a d and rewrite the equation like this. So now we've seen problems like this before, where we want to solve for d and find out which values of d will turn this equation into 0. So we can look at this, and we can look at this to see where d will be equal to 0. So in the blue case, we say d is equal to 0, and then we're done, right? But in the green case, we say d plus 3 is equal to 0, and now we need to solve for d. So we subtract 3 from both sides, and we're left with d is equal to minus 3. Alright, those are our two solutions, but just like we did before, we want to check these solutions to make sure they work. So let's do that. So the first thing, let's check with d is equal to negative 3. So d is equal to negative 3. So we have, plug it back into the original equation, so negative 3 over d, which is negative 3 in this case, is equal to negative 3 minus 3 over 2 times a minus 3. Alright, well, minus 3 over minus 3, that's going to be 1, because they have the same value. So we say 1 is equal to, and then minus 3 minus 3 is minus 6, and then 2 times minus 3 is minus 6. So we can say 1 is equal to 1. That's true. Good, so that works. Now we want to check our other solution, which is d is equal to 0. So we're going to do d equals 0 when we're checking this. So we'll say negative 3 over 0 is equal to 0 minus 3 times 2 over 2 times 0. Now, this should be raising some red flags because we can't divide by 0, right? That gives us an undefined solution. So that doesn't work. We actually have a specific word for what this is called. So we say when a solution is like this, it's called extraneous. So we don't list this as a solution. So extraneous means that it doesn't work. So we can't use that solution. So in this case, d equals 0 was our extraneous solution. So d equals 0 didn't work. So the only thing, so in this case, our only solution would be d is equal to negative 3. So this would be our only solution. Alright, lastly, we want to look at a word problem. So let's take a look at this. So you want to make a scale model of a parade float. The float is 5.5 feet high and 10 feet long. Your model will be 14 inches long, so how tall should it be? Well, the first thing we want to do is make sure we have everything with the same units. So let's change the height of the float and the length of the float. So we have 5.5 feet, right? And we want to turn that into inches, so everything is in inches. So we'll say 5.5 times, and then there's 12 inches in a foot. So 5.5 times 12. This is equal to 66. So that's how high our float is. So 66 inches is how high our float is. And then we have 10 feet, and then 12 inches per foot. We multiply those together, so we get 120 inches. So now we have new dimensions, right? So we can say that our float is 66 inches high and 120 inches long. Now our model will be 14 inches long, so how tall should it be? So we want to look at a proportion problem, right? So we want to say, we'll say that the height of the regular float is to the length of the float as, so we'll say is equal to, so height of the scale model over the length of the scale model. So notice that on the bottom of both of these equations we have length, and in the top we have height and height. So you could set up this proportion in another way. There's multiple ways to solve this problem. So this is just the way that we're going to do it here. So now what we need to do is fill in these variables. So we have the height of our float. So let's fill in that. The height of our float is 66 inches. So we'll say 66 over the length of our float now is 120 inches. Then this is equal to, so we have the height of our scale, but we don't know how tall our scale model should be. So in this case, let's put an h for height, because we don't know what it is, but we want to solve for it. And then over, we know what the length of our scale model is, and that's 14. Now we've done problems like this already, so there's multiple ways we could solve this. We could cross multiply, or we could just see that h is already in the numerator, so we can just multiply both sides by 14 to eliminate it on the right side. So if we multiply both sides by 14, then notice that these cancel, right? They divide to 1. And then if you pull out a calculator, you see that you're going to be left with, so we have 14 times 66 divided by 120. This will leave you with 7.7 inches is equal to h. And there's your solution.